Okay, welcome to virtual algebra class. We're continuing our exploration of all the geometry that you might see on the GED. So today we're going to talk surface area and volume. Surface area and volume. In order to make sure that we understand surface area and volume, I'm actually going to go back to our very first geometry lesson, and that was on the subject of perimeter and area. So you might remember that day when we did perimeter and area by definition. We kind of did a T-table on our sheet where we compared surface or perimeter and area. Similarly, I'm going to do something like that today. So I'm actually going to put surface area right here. And so I'll be able to compare all four of these things. Okay. And we're going to cross the line. And notice I put area and surface area together. Why? Because they're extremely related concepts, and we'll be looking at how they're almost exactly the same thing. And then a totally new concept today of volume. Okay. So when we did, when we talked about perimeter and area the first time, we did it by definition. Do you guys remember what we defined perimeter as?
Around an object.
A line around an object. It's the distance of a line around an object. And a lot of students learned like inside, outside. I really kind of reject that language. So I'm glad you didn't say inside, outside, because if you use that language when you go to surface area and volume, you would be confused. We said that perimeter was a line around a two-dimensional shape. So then how about area? What was area?
Inside, I think. Sort of.
Yeah, that's the language I don't like, not because it's not true, but because it's not clear. Sometimes inside means something else than other times. So if I would describe perimeter as the line around a 2D shape, how could I really specifically describe area?
The lines in. No.
Well, it's not a line at all, actually. When it comes to area, it's actually squares. It's the number of squares to cover a 2D shape. And that might be what you meant by the inside, but because the word inside is kind of generic, I'm not sure. So squares to cover a 2D shape. Does that make sense?
Mm-hmm.
Okay, now when we get to the concept of surface area and volume, we're talking about similar concepts, except we're leaving the world of two-dimensional shapes and we're entering the world of 3D shapes. The real live world that we live in has very few two-dimensional shapes. We can think of a piece of paper like a two-dimensional shape, but it isn't really two-dimensional. It's really three-dimensional. It's just that the third dimension, the width, is so tiny it looks like it doesn't count to us. But really, in the world we live in, just about everything is two-dimensional. We don't just have rectangles. We have three-dimensional rectangular solids. Does that make sense, ladies?
Yes.
Okay, so when we graduate to surface area and volume, we're graduating to a three-dimensional world. And that's really the only difference. In fact, the definition for area is almost exactly the same as the definition for surface area. It's still squares. Area is measured in squares every time. And it's still covering. The only difference now is that I'm covering a 3D shape. Think about if you took a 3D shape like this and you covered each and every side of it with little squares. That's the idea of surface area. And whether or not you ladies realize it, you deal with surface area all the time. Because I bet you've wrapped a present before. Have you guys wrapped some presents? They even have wrapping paper that has the little squares on the back side. Have you seen that? So you can cut it along the squares. So that's a perfect image, wrapping paper of surface area. Does that make sense?
Yes.
In fact, I'll put it down here with my real life examples of surface area. So then what is volume? Well, as soon as I'm introduced to a 3D world, there must be a 3D measurement. Now, you might say, but Kate, isn't surface area a 3D measurement? No, just like regular area, surface area is just a 2D measurement. Even though I'm looking at a 3D shape, I'm looking at a three-dimensional shape like this, I'm covering it with just little two-dimensional squares with surface area. So that in and of itself is a two-dimensional measurement. So area, surface area, whatever, the measurement itself is two-dimensional. And we said that in perimeter, it was a one-dimensional measurement. So similarly, I was going around a 2D shape, but the measurement itself was just a line. It was one-dimensional. Okay, so everybody's cool with that. So now let's look at volume. Volume will be our first actual 3D measurement. The measure itself is three-dimensional. And so if I were coming out in 3 dimensions with my measurement, I wouldn't be covering my shape. I would be filling it. You guys, we have that with water bottles all the time. That's the volume of our water bottle, is the amount to fill it. So this is the number of cubes to fill a 3D shape. Notice 3D measurement, I need a 3D unit. I'm filling it with cubes, not squares anymore. And do you guys know what a cube is? So this was, perimeter was just a line. Area is covered in squares, and now volume is filling something with those little cubes, those little like 3D looking squares. We had said with perimeter, it would be linear measurements because it's just really a line, a 1D measurement, like feet, yards, inches, all those linear measurements of distance, those distance measurements. We had said that with area, and now exactly the same with surface area, It was square measurements, so it would be measured in square units. And do you guys remember how I abbreviated square units because I'm too lazy to spell square feet?
The little 2.
Little floating 2 on my abbreviation. So that's square feet. It's not feet squared. I mean, I suppose it doesn't matter, but it really is square feet. That's the abbreviation for square feet. So square yard, square inches. If you're not United States centered and you're anywhere else in the entire world, square meters, square kilometers, etc. Area, surface area is measured in squares. Surface area and area are synonymous. Just, you know, one is on a 2D shape, so it's just one patch of squares, and the other one's on a 3D shape, so it'll be multiple patches of squares. Okay, so we got that for surface area. Now, we said volume was a 3D measurement, which means we're not going to use a square measurement. We're going to use what's called a cubic measurement, which means we're going to measure in cubic units. Just like that little picture I drew up there, that was a cube. It just will be a cube that's either 1 inch by 1 inch by 1 inch, or a cube that's 1 foot by 1 foot by 1 foot, or a cube that's 1 yard by 1 yard by 1 yard. And so I will abbreviate the same way I did before, and now I will use that little floating 3. That's a cubic foot, a 3-dimensional foot. A cubic yard, a 3-dimensional yard, and so on and so forth. And now you know why we call the second power square and we call the third power cube all the time. This is how they get their nickname. When we looked at perimeter, we found out that you only have really one dimension going around. And so all we ever did was add. When we looked at area, we realized that we ended up multiplying 2 dimensions. Now, sometimes we had formulas where we did more than just multiply 2 dimensions, but area always ended up multiplying 2 dimensions in some way, even in the formulas. Okay. Now, volume, I said, is a 3-dimensional measurement. So guess what? I don't care what volume formula you're looking at or what volume you're finding, in part of the formula, part of the steps somewhere, you will always end up multiplying 3 dimensions because it's a 3-dimensional measurement and they all have to come into play. We have a real life example of surface area. It's that wrapping paper that might go around a box, but let's think of a real life example of volume. What might fill a 3-dimensional shape?
Water, dirt maybe?
Water might fill like a bottle or a pool. Dirt, yeah, dirt. It's really funny that you said water and dirt because 2 of my example problems today, there's water in a pool and there's dirt in raised garden beds. Yeah, very nice. Those are 2 real life examples of something that we would go out and fill 3-dimensionally. Can we think of another real life example of surface area, a covering on a 3D shape? That one's a little harder to think of, huh?
A phone case.
A phone case. Oh, yeah. A phone case would work. Although most of our phone cases don't go all the way around, so we'd have to ignore a side. But yeah, a phone case goes around a 3-dimensional shape. That would work. You know, the packaging on a cereal box, like the actual cardboard on a cereal box. Does that make sense?
Yeah.
So I don't know, if you're putting fabric over a footstool or something, it'd have to be a pretty simple shape because I don't have like volume of an armchair memorized. But, you know, if like I had a little cylinder footrest and I put fabric over the top of it, that'd be another example of surface area. Okay, ladies, so do you think we have a pretty good understanding of what I mean when I say surface area and volume? Okay, sweet. Let's go look at some example problems. I actually have to do the first problem because I screwed up on the last video. I don't know if either of you caught it when you were in class and just didn't tell me because you're very sweet, or caught it while you were watching, but the internet caught it immediately as usual. We used a wrong formula at one point during the last video. So I'm going to correct that mistake and we're going to look at number one here. So number one says, find the surface area of a cylinder with a radius of 4.5 feet and a height of 6.25 feet. Round your answer to the nearest square foot. So this is just a straight up application with a formula involving circles. That's why we covered it last time. But we will go ahead and look at it again since it definitely falls under surface area and volume. So I want the correct formula from my formula sheet. So I'm looking here for the surface area of a cylinder. So hitting up my formula sheet, I go to my third section, which has both the surface area and volume together of three-dimensional shapes. And under surface area of a cylinder, I see this formula. And I would usually ask you ladies for the formula, but I'm really paranoid to do this one right today. So surface area is equal to 2 pi RH plus 2 pi r squared. And because I'm a good communicator, I always start with just my formulas, no substitutions yet. Let's plug into it. Surface area is the thing I'm looking for, so it will remain a mystery essay. 2 is 2. Should I leave pi pi, or should I call pi by one of his approximations? Any ideas, ladies?
Maybe approximation.
Absolutely. Josie, I agree with you. What language in this problem informed you that we should use an approximation?
Round your answer.
The fact that we're to round our answer is proof to me that an approximation will be just fine. I'm rounding anyway. So I'll call pi 3.14. I'll use parentheses because these things are shoved together. I'm going to plug in my radius. Now, they've been nice to me. They've given me the thing I know. I know the radius. However, a lot of students hate fractions. There's already language in this problem that tells me that decimals will be fine with the approximation. If you hate decimals that much, you could just call it, if you hate fractions that much, you could just call it by its decimal form. Do you guys know the decimal form of 4.5?
4.5.
Exactly, 4.5. Students get really freaked out, like, can I do that? Yes, anytime two things are equivalent in math, you may feel free to swap one or the other out for each other if it makes your life easier, okay? So I feel the same way with 6.25. Now, that's the height here. My H is 6.25. Sorry, it got cut off. But students tell me, Kate, I don't know the decimal form of a quarter. And I say, you lie because you use quarters all day long in your life. How much is a quarter worth?
0.25.
Exactly. So 6.25 is 6.25. So even if you can't convert any other fractions to decimals, I would hope you would know your half and your quarters. Okay, are we good with that?
Yes.
Okay, brilliant. Now to that, I'm supposed to add 2. So I'll go plus 2 times pi again. I'll use an approximation for pi, 3.14. And my radius, again, was 4.5. And that is supposed to be squared. And now we will just simplify. I can type that. Oh, I almost lifted up my cell phone and showed off my cell phone, you guys. I can type that entire thing in my TI-30XS. I don't have to even know the order of operations. It's really nice. This calculator can handle it if you type it in exactly the way you see it. So my entire right-hand side is all numbers, no letters, and so my calculator can handle it. So here I go, 2 times. Can you guys do it too? Because if I screw up a button pushing on the internet and am wrong again on the same kind of problem, I think that I'll have to hang my head in humiliation and not do any more YouTube videos. Plus 2 times 3.14 times 4.5. And I use the X squared button to get a square. I got 303.795. You ladies tell me if you get the same thing.
Yes.
Okay, so I did all the work required by the very simple algebra, even though it was an ugly formula. The calculator did the hard work for me. So all that's left to do is round if it's required and give me a unit. So we saw some rounding directions. It said round your answer to the nearest square foot. Where would the nearest square foot be? Anybody, any ideas?
Where you cut the decimal off.
Exactly. When it's at the nearest unit, you just cut it right at the decimal place. So I'm going to cut it right there. I'm going to consider the number about to die. It is definitely more than halfway through my digits. So I'm going to round up the 303 to be about 304. 304 what? Again, this is surface area, so it's measured in square units. So 304 square feet. If I took the cylinder and I covered it with little bitty wrapping paper squares, it would take 304 of those little bitty, well, not little bitty because they're a foot big, but those foot squares to cover up this big old cylinder. Wonderful. One more that's just simple like that. And then we'll graduate to how it might probably look on the GED, since they don't favor simple problems. They like complexity. Okay, there's a little trick to this one. Let's see if you guys can see what it is. Number 2 says, find the volume to the nearest tenth of a cone with a diameter of 12 centimeters and a height of 15 centimeters. So I've been asked to find volume of a cone. What formula should I use?
V equals 1/3 pi r squared height.
This is kind of just a side note while we wrote down this formula. But do you remember how I said that every volume problem involves multiplying 3 dimensions?
Mm-hmm.
Look, there's the height and there's the radius twice, 3 dimensions. You know, there's other things in this problem, but there's always at least the 3 dimensions. So this is the formula I'm looking at. V equals 1/3 pi r squared h. And now I will plug in the things that I know. So volume is what I'm looking for. I don't change equal signs and I don't change numbers. So shall I leave pi or shall I use an approximation? I actually see language that tells me to do an approximation. Do you see where that language is?
The nearest tenth.
Yeah, this language. To the nearest tenth. That's rounding language. Tells me a place value. Okay, so I will call pi 3.14. And I have to tell you, most of the time in volume and surface area problems, a lot of times we just do use 3.14 for pi, but it's not guaranteed. Okay, now I need my r squared. And this is the first place that students usually screw this up. They'll write a 12 right here for r. Can you tell me what I did wrong?
You need to half the 12.
Thank you, Josie. They're not guaranteed to give you what you need. They're not there to do you any favors. They'll give you anything they want. And if they don't give you what you need, you have to go looking for what you need. So they didn't give me the radius, did they? They gave me something related to the radius. What did they give me? The diameter. Beautiful. So let's recall that that's the only thing you are supposed to have memorized about circles, the relationship between radius and diameter. The diameter goes all the way across the circle. So if it was 12 centimeters, the radius only goes halfway across. So it would be half of that, or 6 centimeters. And I'm going to plug 6 in. And you can see how somebody with just a surface level understanding of this concept could get easily tricked. And now I'll plug in my height, because that's the next thing I see. My height here is 15. They actually gave me what I needed. They did give me a height, an h of 15. Is everybody cool with that?
Yes.
Now, some people are mad at me. Oh my gosh, Kate, how in the world am I going to do fractions? You're not. Your TI is. And a little bit more information. This is a problem where I'm expecting a decimal answer. They gave me rounding language, decimal language to the nearest tenth. So you don't even need to bother with fractions on your calculator. You can just use the equivalent divided by for a fraction bar. So I'm going to type 1 divided by 3. Fraction 1/3 is the same as 1 divided by 3. Open parentheses, 3.14, close parentheses. Open parentheses 6, close parentheses. Don't forget to square it with an x squared button. Open parentheses 15, and you guys do the work too to make sure we all get the same answer. I got 565.2. Did you?
Yes.
Directions here say find the volume to the nearest tenth. I do have some rounding language. Tell me how many decimal places that means. The tenth is how many decimal places?
1.
It's just 1. Notice this problem already has 1 decimal place, doesn't it?
Mm-hmm.
If it's not broken, don't fix it. If it already ends at the tenths place, don't try to do something else to it. It's done. You don't have to round it. Life is sweet. It rounded itself. So this is 565.2 what? 0.2 what? What kind of units did we say we use for volume? So volume is a three-dimensional measurement, right? So volume will be in cubic centimeters. Let me see that little floating 3 whenever it is a volume that you're finding. So cubic units, and I'll remind you that cubic units have that little floating 3 when finding volume. Make a note to yourself if you got that mixed up. So perimeter is one-dimensional. Any kind of area, surface area, regular area, is two-dimensional. It's square units, but volume is three-dimensional, cubic units. I've said it a million times. I'll say it again probably another million times before I quit and become a writer instead of a GED teacher. But I wish the GED had a lot of straightforward problems. It doesn't tend to. Sorry. So yeah, Serenity's shaking her head like, I know.
Yeah.
So we got to watch out for different levels of complexities. One of the complexities that will happen with these perimeter area, surface area, volume, all these concepts of measurement is that they won't tell you what you're looking for. You're supposed to know based on how the problem is phrased. If you need a perimeter formula or a surface area formula or a volume formula or what. So let's go ahead and read number 3 and see if we can figure out what we need. So Marty is building, that's my old boss's name. She didn't build gardens, so I don't know why Marty is building 3 raised garden beds in her backyard. If each bed is 10 foot by 10 foot square and 1.5 feet deep, how many cubic feet of topsoil will she need to fill the beds? So guys, what is this? Perimeter area, surface area, volume? What are you thinking?
Volume.
So you guys say volume, and I agree with you. That's brilliant. But I'd like you to give me evidence from this problem that told you that it was volume.
It's filling.
It's filling. We're going to fill those beds up. Only a three-dimensional measurement like volume could fill. What else?
Cubic feet.
How many cubic feet? Right away, they tell us we have a cubic unit. That's a good clue that it's volume. I see one more clue. What are we measuring? Cubic feet of what?
Topsoil.
Topsoil. So that was like you were saying to me earlier, dirt. We could fill something with dirt. We're filling this garden bed with dirt. So topsoil doesn't just cover, it goes inside. You know, it fills up. So great. Lots of good clues that this is a volume problem. So I definitely need a volume formula. The question now is which volume formula? So take a look at your sheet. You've got a lot of different volume formulas, and they might have some unusual names. Rectangular prism, right prism, cylinder, pyramid, cone, sphere. What am I filling if I'm filling this garden bed we described?
A rectangular prism.
A rectangular prism. A rectangular prism is the idea of a box. We usually just call it a box, but it looks like a rectangle on every side, 6 sides that are all rectangular. The iPencil box I kept holding up for you is a rectangular prism. Okay, so notice that formula is super duper easy. What's the formula for a rectangular prism here? V equals what?
L times W times H.
This reminds me of the first day when we were just dealing with perimeter and area of rectangles. Remember how easy it was to find the area of a rectangle? You just multiplied the 2 dimensions. Now if I'm finding the volume of a rectangular solid, I'm doing the same thing, but instead of multiplying 2 dimensions, I'm multiplying 3 dimensions. So let's just plug into it, then it should be super simple. What is now it's interesting because I never use the word length, width, or height in my problem at all. And yet these 3 things obviously are my length, width, and height. So what is the length of my rectangular solid, my garden bed?
10.
Mm-hmm. And the width?
10.
Also 10. Sure. And the height?
1.5.
1.5. And you say, should I use a fraction or should I use a decimal? I say use whichever one you find easier to put in your calculator or do math with. If I were doing this by hand, I'd probably use a fraction because I'd rather do fractions by hand. But since I'm doing it in a calculator, I'll just put in a decimal because I'd rather do decimals with my calculator. 10 times 10 times 1.5. Hey, I don't even need a calculator for that. You guys know why I said I don't need a calculator for that?
Yeah,
Because
Move
Go
the
ahead.
decimal.
When you multiply by 10, it just moves a decimal. So I multiplied by 10 once. I multiplied by 10 twice. My 1.5 turned into 150. Now, the only question is, now there's no ugly decimals here. I don't need to round, so this is a nice exact answer. But the only question is 150 what?
Cubic feet.
Exactly. Cubic feet. This is a measure of volume. We need a cubic unit to fill something. So the volume of that little raised flower bed would be 150 cubic feet. And you really do buy dirt by the cubic foot or the cubic yard. Look at it the next time you're in Home Depot. Look at the labeling on the bag. It will tell you how many cubic feet or cubic yards are in that bag. So number 4. Number 4 says, how many square inches of wrapping paper would it take to cover a box that is 17 inches high by 11 inches wide by 9 inches long? And again, I would ask you, what are they really asking for here?
They're just asking for pretty much like the surface area of the
The
wrapping
surface
paper.
area. We all agree that this is surface area, ladies? I agree with you. That's brilliant. What kind of clues do you see in the word problem that tells you this is surface area?
Wrapping.
Inches.
I heard that. Wrapping. What else?
Cover.
Cover. We're covering the box, not filling it. What else?
Square inches.
There you go, the unit. How many square inches? Tons of clues that this is not a volume problem, even though it is a 3D shape. It's just a surface area problem. We're only covering our 3D shape. So we need a surface area formula. Once again, I would ask you, which surface area formula?
Would it be 2 pi RH plus 2 pi r squared?
Only if you thought my box was circular somehow, like a hat box. That's a cylinder. Yeah. So a hat box is usually circular, but this one just says a box and has 3 dimensions measurement. No mention of a radius or a diameter, so I wouldn't expect it to be circular. What kind of shape am I probably looking at if it's just a box?
Rectangle or a box?
A rectangular prism. A rectangle. And in fact, this is the most common 3-dimensional type of thing. Just like a rectangle is super common in 2-dimensional world. Usually when you don't have any other clues, assume it's a rectangular prism in the 3-dimensional world. So the formula you're going to notice is really interesting. 2 LWs plus 2 LHs plus 2 WHs. And I'd like to just point out, even though we're really just using formulas, that this formula makes a lot of sense. Because remember what a rectangular prism is. It's a box like this one that's made of 6 rectangles. Here's a rectangle, another one, 1, 2, 3, 4, if I go all the way around, and then I have the 2 ends, 5, 6. So this is a rectangular prism, but it's made of 6 flat rectangles. Does that make sense to you?
Yes.
And we know how to find the area of one rectangle. How would I find the area of just this one rectangle? If I was just looking at this one shape.
Length times width.
Yeah, length times width. I would just multiply this times this, right? But there's 2 of these. 1, 2 of these. And look, 2 length times width. See the first part of the formula? But then you come here and now we have this shape. And this might have the same length, but it's got a different height. And again, there's 2 of these. And look at the formula, 2 length times height. And then of course we have 2 of the final shape, and that'll be the final 2 measurements, width and height. And so this one is 2 width times height. And so we see that that's 6 rectangles all in this formula to find the surface area of this rectangular solid, because it's made of 6 rectangles. Of course, you don't need to know any of that if you're just using a formula. You can just plug into it with no understanding at all. But if I'd have been thinking about it last time, I wouldn't have made an error in my formulas. So that's what I get for being on autopilot. So length times width. What do you guys think? What's my length here?
17 inches.
Now, the truth is it actually doesn't matter. I could call any one of them length, width, or height when it's a 3-dimensional thing where they're all interchangeable. But just so some of my students are really easily confused by algebra, I'm going to stick to what I described it as. So just to let you know, again, it would have worked if I'd have called it 17, okay? But since I said my length was long, I use the word long with 9 inches, I'm just going to plug a 9 in under this L so my students with symbolic reasoning issues don't get all twisted on me. And then I said that the width was 11 inches. So I'll have two 9 by 11 rectangles, and I'll have 2 of the length times the height. So again, my length was 9, but my height was 17. I'll have 2 of the 9 by 17 rectangles. And I'll have 2 of the width by the height. So 2 of the 11 by 17 rectangles. And I'm again typing the entire expression into my calculator. Since there are no letters, it's all numbers, I'm totally free to do that. And I got that the surface area is 878. Is that what you guys got?
Yes.
Mm-hmm.
Wonderful. So the question is 878 what? What kind of units would I use for surface area?
Inches squared.
Exactly. I would use square inches. Yes, this is a 3-dimensional shape, but I'm only doing a 2-dimensional measurement. It's like I'm putting paper around the outside. I am literally putting paper around the outside. I asked about wrapping paper. Pretty simple, right? Okay, let's look at a few more complexities. So number 5, Jamil has a circular jacuzzi in his backyard that is 5 feet deep and 7 feet in diameter. There are approximately 7.5 gallons in a cubic foot. How many gallons of water would it take to fill the jacuzzi? Round your answer to the nearest gallon. This is the level of complexity I expect to see on the GED. You're deciding for yourself whether it's perimeter area, surface area, volume. You're having to determine the shape. I'm not telling you the name of the shape. And it's a multi-step problem. Even after you find that volume, there's more to do. This is the kind of complexity they like, so we have to not be intimidated by it. We've got to be able to work through it step by step. So our first step is to find the proper formula. First of all, what do you think? What kind of problem is this? Perimeter area, surface area, volume?
Volume.
You argue volume, and I would agree with you. I'd like some proof, though, from this problem that you knew it was volume. I'm filling it with water. I love that. Yeah, you definitely fill something with water. You don't just cover something with water. Okay, anything else?
Cubic foot.
Cubic foot. Really big clue there that my answer is supposed to be in cubic feet. Of course it's volume if it's in cubic feet. And one more little bit of language. I'm going to take that water and I'm going to fill that jacuzzi. So a lot of clues here that this is a volume problem. Nice. So I'm expecting a volume formula. The question is, they didn't even tell you what shape this thing is. I mean, they gave you some word clues, but what shape am I looking at here?
Circular.
Yeah, I see that clue of circular. But if you look at the volume formula, none of them say circular. So, you know, which one of these things are circular? A rectangular prism, a right prism, a cylinder, a pyramid, a cone? A sphere? Yeah, obviously a cylinder, a cone, and a sphere are all circular. So which one of them would be the shape of a jacuzzi?
Cylinder.
A cylinder. Exactly. Your jacuzzi would be a circle with some right angles that extend out from them with a circle of the exact same size on the opposite side. That's more likely how your jacuzzi is going to look. Your jacuzzi would look pretty silly. So this is a cylinder. As a cone. I've never seen a cone-shaped jacuzzi, and I don't know how we'd balance it if we did. And I don't know what kind of rich person you'd have to be to have a sphere-shaped jacuzzi. Okay, so volume of a cylinder. And what then formula should I use?
Pi times r squared times height.
Pi times r squared times height. And the very excited student goes, yay, volume equals... Most people know to use 3.14 by pi since I have some rounding language. But where I see the mistake, and you guys are probably sick of me rubbing this in already, is that all these students plug in 7 here. Where did that student go wrong?
You need to cut it in half because it's
Exactly, I need to cut it in half. My cylinder is 7 feet in diameter, but this formula doesn't ask you for the diameter, it asks you for the radius, so we'll cut that in half. Mathematically, since I can't half that one super easily in my head, how could I cut 7 in half?
3.5.
It is 3.5. You just knew that. Mathematically, for the student who doesn't know that, what should they do? How could they figure that answer out in their calculator or whatever?
7 by 2.
Exactly. You can take 7 and you can break it into 2 equal pieces. That's the same as halving something, and I do get 3.5. So I'll erase the 7 here. I'll plug in my 3.5 to be squared instead. Notice I close my parentheses before putting my square. And then I'll plug in my h So let's see what my H was.
5.
5 feet deep, depth, height. I'm talking about the same thing here. So 5. So, and now once again, I can plug all of that jazz into my calculator. 3.14, open up parentheses, 3.5, close the parentheses, square it using the x squared button, open up parentheses, and 5. And I get 192.325. Now, I have a lot of people who just round it now, slap a unit on it, and call it done. But watch out, there's a lot of multi-step problems on the GED. This is a multi-step problem as well. There's something I haven't dealt with yet. What haven't I dealt with yet?
Just 7.5.
Yeah, exactly. We've been asked to find out how many gallons of water it would take to fill the jacuzzi. This number isn't currently gallons. I just worked with a bunch of feet. This number is currently in cubic feet. This is a volume measurement. It's measured in cubic feet. So the last and final thing they're asking me to do is a conversion. They want me to go from cubic feet over to gallons. Now, we know that there's 7.5 gallons in each cubic foot. That means in the first cubic foot, there'd be 7.5 gallons. And in the second cubic foot, there'd be another 7.5 gallons. In every one of these 192 cubic feet, I would find 7.5 gallons. Does that make sense?
Yes.
Okay, so I'm going to have to take this number that I just got. Notice I haven't rounded it yet. I never round till the end. And I'm going to multiply it by each one of those, by 7.5 for each one of those cubic feet having 7.5 gallons. Is everybody cool with the reason why I chose to multiply?
Yes.
Okay, I'm going to multiply by 7.5, and it's going to take me a lot of gallons to fill this tank. New number I got is 1,442.4375.
Mm-hmm.
It is in gallons, but now that it's the final answer, now I'll round. I'm going to round to the nearest gallon. Where shall I cut my number?
At the decimal.
Right at the decimal, because I'm talking about a unit. I consider the number that's about to be thrown out. The very next number, it does not matter because it's less than 5. I'm not halfway there yet, so I will say that's about 1,442 gallons. And I'm sorry I sometimes over-explain things like rounding decimals, but those are really tricky for a lot of students. If you don't struggle with rounding decimals, you're lucky. A certain brand of oatmeal is packaged in a cylindrical cardboard tube, 15 inches high with a radius of 4 inches. Hey, I've seen that in the grocery store.
Mm-hmm.
How many square inches of cardboard would be used to create the packaging? Round your answer to the nearest square inch. Now, I thought about including this problem because I realize that on the actual one in the grocery store, it's cardboard all over except the top is plastic. Can we just pretend like the whole thing is cardboard? I'm not trying to do some extra tricky problem, okay? So just assume the entire cylinder is made of cardboard in this case. Okay. So, volume or surface area?
Surface area.
I agree with you, Josie. Can you give me some proof?
It's packaging.
It's packaging. You wouldn't fill the package with packaging or there'd be no room for the cereal. You just put the packaging, and I can't spell. You just put the packaging on the outside of that three-dimensional shape. That's the surrounding part. Okay. Anything else clue you in that this is?
Square inches.
Round your answer to the nearest square inch. How many square inches? Absolutely. Lots of clues that this is a surface area problem. So I need a surface area formula. Which one?
The cylinder.
Absolutely. This one's a little simple. They said cylindrical. I bet it's a cylinder. Nice. So I'll come to surface area of a cylinder on my formula sheet. And it says SA is equal to 2 pi RH plus 2 pi R squared. Apparently I wanted to do this one twice to make up for last time. Okay. And let's see, you guys help me do the substitution. Pi or 3.14?
3.14.
What shall I plug in for radius?
4.
Absolutely. I'm very straightforward with you. I did tell you this time the radius is 4. What shall I plug in for height?
15.
Again, very straightforward. I told you what you needed to know, you lucky snots. Again, I'll use pi for 3.14 for pi. And again, my radius is 4, close parentheses, square it. And as usual, bust out your TI, make sure your answer matches my answer. I'm typing in the entire right-hand side here, the entire expression on the right, exactly as it appears on my sheet. And the TI can handle it. And I get 477.28. So all I need then is round and unit. So do I have any rounding directions? Round your answer to the nearest square inch again, pretty common. So I'll chop it right here at the decimal. This 2 is not halfway through my digit system, so I'll ignore all the numbers back here. And I'll just say that's about 477 what?
Square inches.
Square inches, surface area. Even though it's on a 3-dimensional shape, it's just a 2-dimensional measurement. It's the number of squares to cover. Easy, easy, not hard at all, huh? So I have kind of bad news in that there's a trick to some of these formulas you guys haven't seen before. So I've been doing really straightforward problems, but everybody pick up your formula sheet and look and notice that a few of those formulas have a capital B in them. Do you see how some of them have a capital B?
Yes.
Capital B means something else. And they do tell you what capital B means down at the bottom of that section. Right under the line, it says that P is the perimeter of a base with area B, but I would just write it. I'm going to write it on the side of my formula sheet. You need to know that capital B, not lowercase b. Lowercase b means something else. Capital B means area of the base shape. Area of the base shape. That capital should clue you in that you're looking at a 2-step problem. Anytime we have a capital B, we're looking at a 2-step problem. First, we'll find the area of the base shape, and then we'll take that answer and plug it in for the capital B. So let's take a look at some formulas like that. Number 7 says, find the volume of the prism below. Now, I was kind. I gave you a picture this time instead of describing it in words. But it's only going to help if you know what this is. So I did tell you, I gave you some language to give you a clue, but this is a prism. Or you can call it a right prism, but a prism is a prism. Anybody know? Has anybody heard that word used before? Do you know what it means when something's a prism? Okay, we've actually already seen a couple of prisms before. We've seen a rectangular prism or a rectangular solid. They mean the same thing. And what that is it has a rectangle, and then it goes off in right angles from that rectangle, and then it has a matching rectangle on the other side. That absolutely, the 2 rectangles are exactly the same on the opposite sides. And that's really the deal with all prisms. You have these 2 base shapes that are identical, and then you have these straight up lines. It's just that the 2 base shapes don't necessarily have to be a rectangle. So in this particular prism, they're triangles. Can you see that? I have a triangle on this side. I have a matching triangle on that side. They would be identical. And then I go straight from one to the other. That's what a prism is. Does that make sense to everybody?
Yes.
Okay, so I'm going to need the volume of a prism formula. Volume equals, I look at my formula sheet, and the very second one I see is a right prism. The first one will only work for rectangular prisms. I don't have a rectangular prism because it has triangles on it, so I'm going to use the generic right prism formula. And the generic right prism's formula says V equals BH. Now there's that capital B I was talking about. And so this is one of the reasons why I'm so anal with students who flip on their capitalization all the time and don't notice when they're lowercase and uppercase. Because when a mathematician uses, we have a meaning. We choose different capitalization to mean different things. Okay? So this capital B means area of my base shape. What is the base shape here?
Triangle.
Exactly. So my first step before I can even use this formula is going to be to go find the area of a triangle. So write this, make a little note to yourself, because this is the part students screw up with this. And the good news is I don't see these problems as being super frequent on the GED, but still they're fair game. They're on the formula sheet. They could show up. So first step is find the area of the base shape. So you said my base was a triangle, so I will use the area of a triangle formula. So I'm going to back up to my area section. Area of a triangle is A equals 1/2 little b. Little b is something different from big B. H. So now just looking at your triangle, just the triangle, since we're finding the area of that triangle, I'm going to plug into this. This is 1/2. We said the base of a triangle was always a side, so that's that 6. And the height of a triangle always comes out from a right angle from the side, and you can see my markings with the little square to prove that's a right angle. So my height is 4.2. I could plug that whole thing into my calculator, and I think I'll type 0.5 for half because I'm so lazy. Again, you are always free in math class to interchange two things that are equal. 0.5 is equal to 1/2, so I interchanged it. Typed that in and I got 12.6. So now this is what I'm going to plug in for my capital B. So my volume is equal to the area of my base shape, that was 12.6, times the height of my prism. How tall is my prism? People tell me, Kate, your prism's clearly 4.2, because look at it, that's tall. It's sitting on the table and it's tall. Careful, the height is going to be that length between my two bases. I don't care which direction I turn this in, my height is still going to be the length between my two bases. So this thing, even though it's not standing up, is the height. So the height of a three-dimensional shape is the length between the two bases. Are you guys cool with that? Okay. So that's tricky because one time when I wanted height for the triangle, I picked 4.2. But when I wanted height for the prism, I picked 15. And that freaks students out. Everybody's cool with why my height changed in the two different formulas? Okay. Now then, that's just the math to do. 12.6 times 15. I get 189. Looks like I'm good. So 189 what?
Cubic centimeters.
Exactly. Cubic centimeters. You mad at me or is that okay? This is as hard as it gets. So one more that's similar to that. This one below says, find the volume of the pyramid below. So we said a prism had two identical shapes and we came up at straight angles from that. Two identical bases and we came up at a straight angle from those bases, a 90-degree angle. I shouldn't say straight angle, that means something else. But we come up straight at a 90-degree angle from those two bases. Okay, now when we talk about a pyramid, it's similar, but a pyramid only has one base, and from that base we rise up to a point. Okay, so a pyramid has one base, and from that base you rise up to a point. So can you guys see my base on this shape? Here's my base, and from that base I'm rising up to a single point. Pyramid. Volume of a pyramid formula. Take a look at your formula sheet. What does it say the volume of a pyramid is?
1/3 times capital B H.
Exactly. 1/3 of capital B, and we're good mathematicians, so we'll notice when they use a capital B, H. Almost like the last formula, but only a third of it, which makes sense, because if I'm pulling up to a point, instead of going straight up, I'm going to cut off a lot of that volume. Okay, so it's a third of the base times the area of the base shape times the height. So once again, when you see that capital B, that needs to be your signal. I've got another step to do. My first step is find the area of the base shape. So examine this pyramid for me, please. What is the base shape?
Square.
Triangle?
It's a square. I know it looks all skewed. The three-dimensional shapes look all skewed. And if you're like me, who has a lot of trouble visualizing 3D, this could be a real challenge for you. It's always hard for me. But there's some proof down there that it's a square. Anybody see?
Yeah.
Do you see these little markings here?
Mm-hmm.
They tell me that the four sides are the same, so that's a clue. The angles don't appear to be right angles, but again, that's because it's skewed. So they are probably right angles, or they wouldn't have had to give me different measurements. This is a square, okay? So I've got a square. How do you find the area of a square? Well, even if you've forgotten, according to my formula sheet, the area of a square is just S squared, side length squared. So in order to find the area, I'm going to plug in the side length. What's the side length of my square?
15.
15. There's a side of that square, so I'll plug in the 15 and I'll square it. So my area is 225 square inches in this case. I can write it. It really doesn't matter if I write it now. I want my unit, my final answer, but I'll be clear. Okay, is that cool? Now I have the capital B that I needed. Now I have the area of the base shape. So I can plug into my volume formula. So volume is equal to 1/3 times that area of the base shape, which I just figured out was 225 square inches. And I'm going to times that by that third dimension, that height. And the height of this pyramid, you can see the height, I should have marked it with a right angle, but the height always goes at a right angle from that base to the tippy top of my pyramid. So this is my height, it's 13. I'll make a little note to you in case you need it for your notes. The height goes at a right angle from base to the top of pyramid, which is like the height of the last shape. It was one at a right angle from the base as well. It just went from base to base because we have two bases on a prism, but down here we only have one base. Okay, so that's what I mean when I talk about the height of a three-dimensional shape. Again, when I plug this into my calculator, this is not necessarily a problem where I need a fraction. So I would probably say 1 divided by 3 because I don't want a fraction answer. So 1 divided by 3, open up parentheses, 225, close parentheses, open up parentheses, 13. And I get 975. Did you get 975? Okay. So just the question then is 975 what?
Cubic inches.
Cubic inches. Volume is a three-dimensional measurement. Surface area would be in inches squared. Almost just like the last problems. We're going to get to practice this one more time, except for this time I did not tell you what type of shape you have. You're going to have to decide for yourself. I just said find the volume of the object below. So clearly I want volume, but what kind of a shape is this?
A pyramid.
A pyramid. Exactly. We have a base down there at the bottom. We're coming up to a point from this base. This is a pyramid. So once again, my volume of a pyramid formula is V equals 1/3 capital B, meaning area of base shape, times height of my pyramid. So my first step has got to be find that B, find that area of the base shape. What is the base shape in this case? There's my base. Ooh, what kind of a shape is that?
Triangle.
That's a triangle. So I'm going to get the area of a triangle formula. A equals 1/2 base times height. Does everybody understand why I picked this formula? Yeah, you have to determine the shape of your base before you choose how to find the area of it. And the shape of my base was a triangle. Okay. Now be very, very, very careful. In this right now, I'm only looking at this triangle. I'm looking at the area of this triangle. So I want the base and height of this triangle in my formula. So area equals 1/2. What is the base of my triangle? Well, remember, a triangle's base is always one of its sides. I only have one side of this triangle labeled anyway. What'd you say?
25.
Absolutely, there it is. That 25 I know is the base. Now students get mad at me when the base isn't on the bottom, but I could tell for sure, even if that wasn't the only one labeled, that that's the base, because I see this height of a triangle coming off of this. I see this measurement that extends from the side to the tip at a right angle. Of course, that's a height of a triangle. And so I plug in 11 for the base and height of the triangle. And notice it makes a little T on my triangle. Again, you can use your calculator, and I will do 1 divided by 2 times 25 times 11, and I get 137.5 for the area of my base shape. And of course, it would be square millimeters. Don't get so excited that you found the area of the base shape that you forget to go all the way. They asked you to find volume. So I need to take that area of a base shape and plug it in for the capital B, because that's what capital B means. So to find the volume, I'm going to take 1/3 times this number I just found, the area of the base shape, and then I'm going to multiply by the height. But careful, now I'm finding the volume of the pyramid. So now I want the height of the pyramid. How tall is the pyramid?
23.
23 millimeters. The height of a 3D shape goes from the base to the tip similarly, but through that 3D shape. Okay, and I'll plug it all into my calculator again. I'll do 1 divided by 3, open up parentheses and put in that 137.5, close parentheses and put in that 23. And I don't know why I wrote the millimeters there. It doesn't matter if you do, but I don't usually do it. So I get 1,054 point a lot of numbers. Now, I should have had the foresight to give you some rounding directions. I did not give you rounding directions. So I'm just going to leave this problem just the way it is. If you ever had a number you were forced to round, like this one I'm forced to round because it keeps going on without ending. If you ever had a number you were forced to round on the GED and there weren't rounding instructions, either it would be a common sense problem, like it's money, so I better round to 2 decimal places. Does that make sense? Or it would be clued in by the answers. There would be like multiple choice answers and they would all be round to the same place or something like that. Okay, so since I don't have any of those clues, I'm just going to leave this number be exactly the way it is. Let's get a unit. What would be the unit on this volume?
Cubic millimeter.
Cubic millimeters. We did volume and surface area. There's only one thing we haven't dealt with here, and that's okay. We've done enough for today. So I'm just going to call this a day because we've covered a lot of ground. Complex, but not impossible. And again, our calculator does most of the work. Thank you guys for showing up. As always, I love not talking to myself. And hopefully I'll see you guys next week.